100.
Day 100.
Never thought I would make it.
Never thought I would make it.
I'm here.
I'm here.
New scenario,
New scenario.
new me,
New me.
same old laptop.
Same old laptop.
Look at that. It's acting up. I don't know what it is.
Acting up. I don't know what it is.
Whatever.
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 Oops.
Oops.
La 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 la.
La 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 la.
Goo goo gaga. Okay.
Goo goo gaga. Okay.
Perfect.
Perfect.
Everything is.
Everything is.
Everything is gonna be perfect.
Everything is gonna be perfect.
Nothing's.
Nothing's gonna.
Bro, perfect
Bro,
setup.
perfect setup.
Not even joking.
Not even joking.
Can I sit? If
Can
I
I
could
sit?
sit, this will be like
If
the
I could
perfect
sit,
setup
this would be
ever.
like the perfect setup ever.
Bro, oh,
Bro,
I'm. What am
I'm.
I?
What am I?
This is the setup.
This is the
Let's go.
setup. Let's go.
Okay, not gonna fall.
Okay, it's not gonna
If
fall.
it falls,
If it falls,
it falls.
it falls.
What can I do?
What can
Right.
I do?
What
Right.
can this nigga do?
What can this nigga do?
So,
So,
you have like a couple of
you have
second
like
lag,
a
but it's
couple of
fine.
second lag, but it's
How
fine.
do I?
How
How
do
do
I?
I set?
How do I offset?
I think this is
I think
fantastic.
this is fantastic.
Okay.
Okay.
Wouldn't that be crazy?
Wouldn't that be crazy?
It'd be crazy. I can sit.
It'd be crazy.
Isn't that
I can sit.
wonderful?
Isn't that wonderful?
Bro, it's so laggy. What the hell?
Bro, it's so laggy. What the hell?
Okay, I think we're doing a little change of plans. Change of plans. Nothing serious. Oh, get this. Oh, fuck. Fuck shake, bro. Oh, okay. Okay. Hope you guys seeing what I'm seeing. Oh, I can't even have synchronization, which is God. Can't have synchronization. What? Continue with Apple. Am I gonna? Oh, for fuck's sake. Just. How do I sign out? How do I sign out? It's just like beyond me. How. Please, can I sign out? While I'm at it, I need to do some admin work. Not admin work. I need to do a lot of syncing, lot of stuff. Might as well do it now. Bro, confirm. Yes. Oh my holy. I wanna beat some. She's out. It's like. Yeah, it's like. Bro, who the fuck is Sean Movich, bro? Sean Movich. Get it right, motherfucker. Okay, now I need to sync. Please sync. Sync, sync, sync. Okay, stop. Get it, bro. Like you think. Sync, where is sync? Oh my. Count. Sync. Is there an option for sync? Fucking dumbass bitch. Give this nigger. Sign out. Okay, finally. I think um yeah, I need to reevaluate some things. Brave tech. Okay. What do I do?
Thinking if I were starting today. Freaking out.
Deep ML. The crazy thing is, I hate this thing. I hate chess. I hate chess. I hate chess. Oh, should I do it that way? Let me try. What do you guys see? Oh, what am I looking at? Oh my god. This is so stupid. You're stupid. You're a stupid little shard.
Okay.
Okay. It took me
30
30 minutes. Still haven't done it. Still haven't done it. Vision board, he can die for this. Probably. 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 High likelihood. So let's try. What? Just give me the Fucking. I don't like you. I don't fucking hate you. Fucking hate you. Just give me the fucking runs. I'm gonna fuck out of you. Please. Holy! Let's write a Monte Carlo simulation. Let's do some. Roadmap hates it just. Yeah, let's watch some YouTube videos on. Today's 100th day, so let's chill out. Watch some math videos about GN and something like that. Let's try the yellow. Yeah, good. Bro, comment Wilson for sure. Yeah. Yeah, it's winning, nigga. It's winning. Citations, productivity project, clean UI. I'm going bald. Hello. Lot of hair. Yeah, it's a very poor every text. Fuck. Nigga, you don't have it in Windows. Fuck you. I think Perplexity has an Android market in. So that's 1 for 1. Bro, it's still loading. Holy. Again. It's probably all made up. Let's see. What are you gonna say? Statistics, probability.
Probability is an invention, it's a concoction that we humans. No wonder we're so bad at it, because we just made it up. It's not out there. Probability is an expression of personal uncertainty. It's a personal expression of ignorance about a degree of belief. No ignorance might be about the future, ignorance in the past, but it's a relationship between us and the outside world. It's not a problem in the outside world. It's all our different probability. It's an invention, it's a concoction. Just make it up.
Let's see the 7 levels of statistics. Bro, that's fake. I need to write a comment. Bro, Challenger is so. What is the least credible probability? It's gotta be 1. Is Perplexity in Linux? Comet? The bottleneck is it's in the hardware. It's not actually in the software. So it doesn't matter how slowly it runs, because the bottleneck is actually in the software side of things. Learn statistics. How do I learn new statistics quickly? Learn statistics deeply. Okay, whatever. Let's put this over here. Yeah, I mean, bro, what the fuck is this? Nigga, I will beat the fuck out of you. Come on. I'm gonna go crazy. I'm crazy. Oh. Can I do that? I need to try. Trying new things. You know what I mean? Can I start two streams at a time? Okay. I'm in 2 different streams now. And I want to end this stream, but I don't want to. So what I'm gonna do is, this is some high level shit. So you get to see my face on this stream, and you get to see my actual. Bro. Just say it, bro. Okay,
Just say it, bro.
let's give this a shot. Not gonna do anything today. I'm not gonna getting off this chair till
Okay. Let's give this a shot. Not gonna do anything today. Off the chair.
not gonna
Do anything today.
my headphone. I mean, Polymer News.
Fantastic. Fantastic. So, first off, it's really great to have you all here today. I really appreciate it.
In this video, I want to teach you how I learned statistics quickly and deeply. I've been working at my job for 4 months now, and it showed me that there's still an ocean of topics that I don't know about, and that I needed to know about them yesterday. Learning on the job is expected, but I've seen that people who can do this fast are the ones that get noticed and make the most impact. I'm developing my own workflow for doing this, and I wanted to share it with you today. Whether you're already experienced with statistics or a total beginner, I think there's something here for everyone, especially since we're all grappling with the presence of AI in our lives. If you're new here, then this is very normal with veteran statistics. I got the idea for the recently asked to use a model, then I delivered an analysis of covariance. Before, I hadn't. I've already gone through the process of learning it at work, but I made it a point to take notes throughout my entire process. What you'll be seeing is my literal thoughts while I'm learning. The first step in my process is to get some sort of formula or representation of the model. If I need to use it, then I should know what it looks like and what it's saying, right? My go-to place is Wikipedia, the Uncovapedia, and go to the page for that model. This will work for very common models, but for some niche or cutting edge, then I'd probably look to a textbook or the paper that proposed it. According to Wikipedia, ANCOVA is a general linear model that blends ANOVA and regression. I'm not really sure what blending means, but this at least gives me a solid background. I know that ANOVA can be viewed as a special case of linear regression, so maybe ANCOVA is the same as well. It compares whether the mean of a dependent variable are across one or more categorical covariates and one or more continuous variables. And the hypothesis test compares many means together at the same time. That's pretty similar to an ANOVA. Then they go into some intuition stuff, which I don't need right now. I just need the model specification right here. So here's what we got. I see there's a YIJ here, so it's an outcome with 2 indices. And there's also an XIJ here. So I assume that represents a covariate that has an association with the outcome, the continuous one mentioned above. There's also this weird X bar, which usually indicates some sort of average. So I'm guessing this term indicates that all the covariates are mean-centered in some way. Then there are the parameters. There's a mu here, a tau here with an I index, a capital P, that's paired with the covariate, and finally an epsilon term, which usually indicates some noise that makes it hard to distinguish between group means. Notably, mu and capital B don't have group indices, but tau, so I know what things will differ between groups and which will be the same. But I know what they are, I need to go back to how I should interpret them. So J represents the index for the observation, but then the ith I is for group, J is for a particular outcome in the group. Mu is a grand mean. It's like the average of all the outcomes across all the groups. So I think the average of grand covariate mean. Tau is described to be the effect of being in the ith category. Statistics effect usually refers to some sort of change. That's how being of one group changes the average relative to the grand mean. In my field of biostatistics, this usually has to do with comparing a placebo group against a treatment group. Here it's comparing a group mean versus the grand mean. So it's slightly different, but similar idea. It tells me that tau is actually the number of interest here, since it tells us how the groups differ in some way. B captures the change in the average outcome associated with covariates. The B here is more to adjust for the effect of these continuous variables. And as epsilon term, this seems like an error term similar to other regression models. I got what I needed for this. That doesn't hurt to scan the rest of the article. There's a pie chart here with a model stance visualization here. I don't like this way of linear regression, but each one model is the same. All groups here experiencing changing outcome for change in covariate, reflected in the B term. In plot, the group means are different when x equals 0. But the article specifically says that it tests whether or not these are the same. So under the null hypothesis, the plot should look like this. While the original form presents an alternative where they're all different. I looked through this article, but the other way to do it was with AI. While I have a lot of reservations about U and AI, but usually AI has to do this. If I use a bunch of stuff I don't quite need yet, but I do see the model specification here. If I take this and compare it against the Wikipedia version, I can see what parameters correspond to what and how I should interpret them. Okay, editor question here. For some of the things I'm pointing out will make sense to you because you won't share the same background knowledge as me. And I'm sorry if you don't quite understand everything, but the point of this video is to show you my learning process, not teach you on ANCOVA specifically. If you could just say one thing from this video, I hope that fast and deep learning comes from developing a dense network of knowledge and adding to over time. This video showcases specific actions and questions that I ask myself to cultivate. It might look different in the case, but this is a general process. Fortunately, I could turn this into a video is that you can get the illusion that this only takes a few minutes. But in reality, that's a good part of work.
Pharmaceutical
With concepts that take several days. My process is actual use cases for the learning. Step one, perfect is to do the model, but I'm able to apply this to the top. We can use case, no, where's the student at my industry? Where's the definition of that I do are clinical trials. Clinical trials are a great place to learn. They're highly regulated, which means that the barriers to them much higher. Recently, I'm seeing a lot of news about them. But the most consequential technical name for that is one of the most important trials was Novo Nordisk registration package. Some approved obese and overweight population measured as a percent change in the weight compared to baseline. Of course, Novo Nordisk was interested in proving that sema would result in more weight loss, and two, which both compared sema against placebo for weight loss. I can see that they estimated that sema produced a 12% for placebo, so this negative 12% has to correspond to the model. The treatment group is had 1 to the tau. This is the parameter that Novo Nordisk would be the most interested in, and seeing that it had a low p-value. But looking at the model, there should be some covariates added to the ANCOVA. So for completeness, I want to know what they are. I couldn't find them on clinicaltrials.gov, so I went back to the published manuscript for the trial. Since tau is the main thing that Novo Nordisk would want to report, it's unlikely that they would report the coefficients for the other covariates. They're more for adjustment. So reading through the document, I found what I was looking for. Table 2 summary the information on all their primary and secondary endpoints. In the footnotes, you can see this. Continuous endpoint analysis for the analysis of covariance method with randomized treatment as a factor and baseline endpoint value as a covariate. So they just for a single covariate in ANCOVA the baseline measurement endpoint. This would control for the fact that everyone in the trial starts at a different weight, and I can see how this might influence how much weight they would lose for the trial. Furthermore, I want to highlight the slight change in notation. Instead of using a grand mean mu, I've changed it to a beta 0 represent weight of the placebo group. No Nordisk is interested in saying how well the treatment compared to placebo get a grand mean switch. However, this is on ANCOVA with only two groups, placebo and sema. We can argue that ANCOVA easily have 4 groups, and I want to see how the reports like that. Save some time, I'll just show you example to identify it with another sema study. If this one then people have type 2 diabetes, this is no Nordisk was trying to figure out and look at with multiple receptors compared to before placebo. And they listen, you can see that there's multiple things placebo. You're looking milligrams. Each of the numbers was differently made it easier to see what specific covariates was and HbA1c. To be honest, when I was had to use ANCOVA trial, I decided
So I'm consuming statistics now.
Step 3 in the process is to start working.
I think
The first 2 steps
typing
will
it out
involve being a
or
statistic consumer,
will
just
always
reading
be
about and
the
understanding the model
best
itself. Ultimately, I'm going to
Interesting.
need to be able to use it in my projects. So I need to be a statistics user. This means I need to be familiar with the statistical programming for ANCOVA. Similar to step 1, this can be done by either Googling R ANCOVA or Python ANCOVA, or you can just ask AI for a faster answer I need to check. If AI is better providing coded advice. Claude tells me that the AOV function implements ANCOVA a helpful example to copy. Claude also tells me that I can use linear regression as well, which I already suspected. I've never used this AOV function before, so I'm going to dig into it a little bit more. The way I do this is by reading the documentation for the function. Sometimes online posts can be helpful as well, but in my experience, the documentation plus AI will get you most of the way there. The documentation tells me that the AOV fits an analysis of variance model and ANOVA model. Furthermore, use the LM model, which implements linear regression. Should I be concerned? Not really. One of the unfortunate things about statistics is that a single model might be given multiple names. This is why it's important to look at the model specification first. In the end, ANCOVA really is just a linear regression with a specific set of covariates, a categorical variable of interest, and possibly many covariates that can either be categorical or continuous. So in that respect, Wikipedia was actually sort of wrong here. It focuses on the nature of the data itself. Rather, this is why looking.
Hello, scholars. This is Fahim. Finally, I have been waiting for.
Bro, is game engine that fucking... I guess this is a lot of gaming.
Fellow scholars, this is 2 minute papers with Carol Joanna Fahir. I have been waiting for quite a while to cover this amazing paper about AlphaZero. We have talked about AlphaZero before. This is an AI that is able to Go and Shogi, or in other words, Japanese chess, on a remarkably high level. I will immediately start out by uttering the main point of this work. The point of AlphaZero is not to solve chess or any of these games. Its main point is to show that a general AI can be created that can perform on a superhuman level on not one, but several different tasks at the same time. Let's have a look at this image, where you see a small part of the evaluation of AlphaZero versus Stockfish, an amazing open source chess engine which has been consistently at or around the top computer chess players for many years now. Stockfish has an ELO rating of over 3,200, which means that it has a win rate of over 90% against best human players in the world. Now, interestingly, comparing these algorithms is nowhere near as easy as it sounds. This sounds curious, so why is that? For instance, it's not enough to pit the two algorithms against each other and see who ends up winning. It matters what version of Stockfish is used, how many positions are the machine allowed to evaluate, how much thinking time they are allowed, the size of hash tables, the hardware being used, and so on. For the side of the desk committee, these are the details that matter. However, from the side of the matters most is to create a general algorithm that can play at superhuman level. With this constraint, it would really be a miracle if AlphaZero were able to even put up a good fight against Stockfish. So, AlphaZero played a lot of games that ended up as draws against Stockfish. Not only that, but whenever there was a win, almost always AlphaZero. Insanity. And what's quite remarkable is that AlphaZero has only trained for 4 to 7 hours only through self-play. Comparatively, the development of the current version of Stockfish took more than 10 years. You can see how reliably this AI can be trained. The blue lines show the results of several training runs, and they all converge to the same result with only a tiny bit of deviation. AlphaZero is also not a brute force algorithm. It evaluates fewer positions per second than Stockfish. Kasparov put it really well in his article where he said that AlphaZero works smarter and not harder. Even Magnus Carlsen, chess master extraordinaire, said in an interview that during his games he often thinks, what would AlphaZero do in this case? Which I found to be quite remarkable. Kasparov also had many good things to say about the new AlphaZero in a, let's say, very Kasparov-esque manner. And also note, the key point is not whether the current version of Stockfish Go was used. The key point is that Stockfish is a brilliant chess engine able to play Go for any game other than chess. This is the main contribution that DeepMind was looking for with this work. This AI games at once, and a few more papers down the line, it may be able to master any perfect information game. Oh my goodness, what a time to be alive. We have only this video. This was only a taste of the paper. The evaluation section in the paper is out of this world, so make sure to have a look in the video description, and I am convinced that nearly any questions one can possibly think of is addressed there. I also linked to Kasparov's editorial on this topic. It is short and very readable. Give it a go. I hope this little taste of AlphaZero inspires.
Bro, this guy's so cracked. It's crazy. He's like a fucking genius, not in joking. How do you become that fucking good? Bro, this guy is so fucking cracked. Networks. Bro, I think he's like made in a industry. He's made in a vacuum. He's not real. This guy, why is this guy so smart? Accomplishment. I can't even spell accomplishment. This guy is so fucking cracked. It's crazy. He has become a chess master by the age of 13 over and won 5 world championship in a tournament. At 17, he co-designed the award-winning game theme park selling millions and laid AI black and white in Lionhead Studio, DeepMind breakthrough. He co-founded DeepMind and acquired by Google in 2004, pioneering reinforcement learning. Bro, he literally like found reinforcement learning. Isn't that crazy? Mastering algorithms in superhuman levels with raw pixels AlphaGo. Defeated Go world champions like, okay. Scientific impact. AlphaFold Paul. Oh my god. 50-year-old protein folding problem with atomic accuracy. AlphaFold predicted near all proteins released freely from alpha extended and DNA are in genome. Let's go to Newcastle. Bro. This guy is so cracked. Parents. PhD in chemistry. Bro, the thing is, he's a dork. Like a skinny little dork, but oh my. Let's see, bro. Something have to like you cannot be this smart. You know what I mean? Being this successful and smart is like, if you have like a good wife and a kid, brother. Good for him. Truly a rags to riches story, you know. Like you cannot hate this guy. Grew up in a modest family. I don't know, like he might be into something. You know, he might be. I don't think so. He looks like a serious guy. But homeschooled chess guy, yeah, perfect.
This I got to do a workshop with you all last year, and it was a lot of fun.
Okay, I need to. What do I need to do? I need to get. I'm dilly-dallying around. Fuck, I hate bitches. Don't say LinkedIn. I don't want to sign in on LinkedIn. like email every one of these guys. Full stack general experience. How do I? Bro. What the fuck am I doing? Bro, bootcamp instructor, nigga, what? We have seniors making, oh my lord. Bro, how the fuck am I supposed to, oh my. Senior mobile full stack engineer. Yeah, it's definitely possible. Yeah, full stack is the way to go. full stack, front end developer, data scientist. Looking for someone with 75 experience in data manipulation, has a master's. Yeah, makes sense. Okay, cool. Software developer. Focus on more Linux kernel system development, administration, configuration, proficient with C++. Nah. How am I supposed to convince you? Like, tech lead, internet analyst, lead engineer, data scientist in AI remote. Bro, I need to shoot every shot. Fuck. Ooh, I should make that. I need to write that down. I need to whiteboard all of this shit. But anyway. But anyways. Yeah, let the goyim deal in the real world. Um. Be hungry. Product hunt. Launch.
Fun, so I appreciate it. Getting to do it again. And so last year, I gave a talk on the MIT Summer Institute on optimal control methods. Optimal, which I enjoyed giving, and it's still online if you want to check it out. But one of the things that we kind of took for granted when I did that workshop was that you all know how to simulate the movement of an organism, an animal, a robot, in my case. So we try to sort of back it off a little bit here and have our time be about how you simulate match, because I don't know about you all, and you learn how to computer simulations. I'm Vicky. I'm an associate professor
These
of
guys
mechanical
want to
engineering.
be transhumanists.
I am
It's
doesn't
fine.
say biology. I love collaborating with disciplines and movement science. So I'm going to talk.
I'm resource maxing right now. Deep ML. No. I need all the resources. Let the king see. Let the king see everything.
If I were starting today, forget about watching courses. The first thing I do is start with more fundamentals and practice coding. Great, just this is possible courses. solve ML problems instead of just watching animations. First, it has repo-style ML problems made by engineers creating tables and backgrounds for non-nonsense. This is one time it's super interesting. It's really cool. It's a program feature where you can see visual simulations. If you're new to ML, the scaling path gives you a structured roadmap with calculus, linear algebra, and stats with over 90 problems in accomplished time, so you know how you're doing. And people have other
Bro, no fucking way this is cool. No fucking way. Deep learn, bro. No fucking way. Might even pay for the premium. Probably not. Scrumba. I need a knowledge max. Just give me the link. Bro, why do you need merge sort of color? Why do you need that, bro? Why do you need that? Oh yeah. Bro, I'm gonna be the most cracked industry knowledge guy ever. I'm procuring resources right now, so.
about that.
About how you simulate movement, because simulation is something you do a lot in my field. So, you know, many of us know all about, have seen a lot of Monica's work. Make sure we get this going here. All right. So here's an example that moves. Monica's, I think, our subject, but probably what you're most famous is the guinea fowl. We've seen videos of these things run around on obstacle courses very stably, and they move, right? And experiments are so important for getting data out of. And I was actually put on with Monica back when but my field is less about animals directly, and my subject robots. I work in robotics. Okay, so where do we connect? A lot of it is in the field of how simulation. Okay, that. Okay, well, for robotics, the reason we want to have simulations is we want to be able to write controllers. And so one thing we will do is we will take a robot, we'll write computer simulation, and have an algorithm try to optimize how the simulation moves to come up with a controller for a walking robot, and that's what this here is. So, the first thing we had to do before we control this robot was how to simulate it. Okay, and so that's my specialty, and doing the control. Importantly, for governance, the simulations are it offers another way to interrogate or right. She used a pretty simplified math model right here, what's called a spring-loaded inverted pendulum, to model how this guinea fowl steps into an obstacle and then falls forward, and yet still maintains its stability. Okay, so simplified, and to do that, Monica had to write a computer simulation of movement, right? And from my standpoint, from a robotic standpoint, math models are also important how you design robots to control them. If you have some simple bio-inspired model simulation to inform how your robots are built as well as control them. And theoretically, if you have a reasonable bio-inspired model that guides your control and your design, you can end up with like movement as a hypothesis that we thought about. And math models, this is open, which allows your models to be complementary, probably thinking of simulation models, but model right is that this little rat is running away from some kind of owl, and you have a very simplified model, which is just a